Introducing health and wellness advocate, veteran international real estate investment expert, author and speaker, Adiel Gorel.
Health tips, fitness tips, nutrition and well-being, world-class experts, all right here on my podcast, The Adiel Gorel Show. Hi everyone, it's a pleasure to be back with you again. I'm especially excited today. We have Roger Seheult with us, Dr. Roger Seheult. And Roger, welcome to the show.
Thank you so much. It's really a pleasure to be here, Gorel.
I've been watching your materials. I watched you on podcasts, and you are clearly a renaissance man in the fields of health. And we could be here for 7 hours talking about everything that you talk about. Of course, we're not going to do that. And I know about your, the point that you have. But I would like to focus today, and probably that's what most people do when they talk to you, about the sunlight.
Absolutely.
Darkness at night and artificial lights, the mitochondria, near infrared. I think that'll give us enough meat on the bone, so to speak.
I agree with you. There's a lot there.
So when it comes to all of that stuff, and just in general, maybe you can give us a little background.
Yeah. I have looked into this primarily because of what has happened in the last 4 or 5 years in terms of our sudden interest in health. But I've come at it as well from a healthcare provider standpoint, not only taking care of patients in the intensive care unit, but also what I do on the outpatient side, which is sleep medicine and circadian rhythm. And really where sunlight and darkness and sleep meet circadian rhythm, all of this is integrative. So basically, to start, we as human beings really are designed to have light when it's time to have light, which is in the day, and to have darkness when it is time to have darkness. We see this quite a bit, these two extremes that are both beneficial for human beings. And it's all a matter of timing, just like everything else. Like exercise is important, but so is rest. Light is important, but so is darkness. And how that all fits in is very complicated, but it's easily able to be worked out. And here's the good news, is that there are some very simple, actionable, low cost, very inexpensive, dare I say free ways of implementing some of these things that can actually have a tremendous benefit on people's lives.
Yeah, I completely agree. And actually, that's the gist of why I have this podcast. I love to bring the message down and make it simple, because sometimes I talk to people who are in a very, refined place and they talk in that way. I bring them down to earth. What can we do today? What can we do? So I love to hear that you speak like this.
Yeah.
And also what could be useful to people. And this is a big, big, big topic, because every day that goes by, the situation worldwide really gets worse.
Yeah.
It gets worse. I would almost say it gets worse, exponentially. So, if you can tell us, why do we need the morning light?
Yeah.
Why do we need the light in the daytime? What does it do to us?
Exactly. So there are two main threads, two main reasons why sunlight, and we're going to stick to sunlight, and then from there we can deviate and talk about why some of the things other than sunlight may not be as beneficial. But let's talk about sunlight. And there's two major threads as to why this is helpful and beneficial. There is the sunlight that goes into your eyes and interacts with your retina. And then there's the sunlight that doesn't do that. There's the sunlight that actually, we have great data now that shows that sunlight literally passes through your body and can be measured out the other side. That sounds incredible, but we have hard data that actually shows this is the case. So I think we could probably start with the thing that makes the most sense for most people, and that is light that goes into the eyes. So what is it? Why is this important? It's because, let's back up and let's talk about circadian rhythm. So I have a friend that worked at Disneyland for many years, but he worked at night. And when he worked at night, that park, Disneyland here in Southern California, is a completely different park than you would possibly imagine if you were to visit there during the day. There are engineers that are shutting down the rides and testing them. There are gardeners that are weeding the gardens. There are people who are cleaning out the cash registers, restocking the gift shops. These are all things that cannot happen during the day when you go to Disneyland, because it's going to ruin the experience. Disneyland is not going to be the park that the owners want it to be during the day. But to have it that way requires something else happen at night. Can you imagine if the engineer showed up during the day and shut down Space Mountain, for instance? That would take away from the effect of visiting that park during the day. And the list goes on and on. I think you get the idea. Our bodies are far more complicated than Disneyland. And yet, that very simple thing needs to happen. There are numerous complicated things that we could get into the weeds. But let me just say this. There are many processes that are occurring at night, some of which we understand, some of which we don't understand yet, that are imperative in making sure that when you get up in the morning, you are as pristine, as clean, and as ready for the day as the Disneyland park is at 8 o'clock in the morning when they let their first visitors in. And so you can already see there how important it is for circadian rhythm to be on track, making sure that things that are happening during the day are happening. And to the flip side of that, to make sure that things at night are not happening. And the things that are happening during the day are ruled by light, and the body has grown accustomed and is hardwired in that if it sees light, it's going to be doing the things that it normally does during the day. And if it doesn't see light, so the lack of light is darkness, if it quote unquote sees darkness or is in darkness, then that's going to allow all of those things that are supposed to happen at night to happen. And so you can already see there's an issue where if we are starting to do bright lights in general at night, that's going to be a problem. And if we have darker days that are not telling our body that it is the daytime, we're going to have a problem there. Now, there was a paper that was published just last year, and the paper was titled Dark Days and Bright Nights. And this was an incredible study where they gave watches to individuals with light sensors on them. They were just sensing visible light, and they were able to granularly actually measure the amount of light that people were getting by the hour, okay? And they were able to measure this for for weeks or two, and then they were able to extrapolate over years and follow these people to see what actually happened to them. Many subjects in this study. And what they found was very interesting. They were able actually to plot out by the hour what happened to the people that received 90 percentile of the light. In other words, which people received the most amount of light throughout the day and the night, and they could see what would happen. It was very amazing. So people who had the most amount of light exposure during the day actually had reduced mortality rates. In other words, their mortality rates were significantly reduced. And then right about 10, 11, 12 o'clock at night is when these granular bars by the hour suddenly flipped and went over 1.0, meaning that now light was no longer a benefit, it was a liability. Now these people actually started to die more likely than they would have if they did not have this bright light. Now think about that. That's a huge endpoint where we're talking about the effect of simply light can actually affect not just how you feel, not just depression, not just sickness, we're talking death. So you can imagine how powerful this effect. And so why is it important? Your first question, why is it important for people to get bright sunlight in the morning? Is that bright sunlight, first of all, is the brightest thing around at that time of day. It's brighter than the light in your room. It's brighter than watching television or opening up your iPad. The sun that you get in the morning is the brightest thing that's available to you. And brightness matters because it tells your circadian rhythm that it's daytime and it needs to start getting ready for the day and processing it. You get higher cortisol levels. You suppress, you actually shift the circadian rhythm a little bit earlier so that you can feel sleepier and go to bed earlier. There's a number of reasons why. There's a second reason why, and that is another pathway in the eye that goes back to the brain, to the master clock. There's another one in addition to that one called the perihabenular nucleus. And so when you get bright light exposure into your eyes going to that area of the brain, that actually reduces the chances of depression and specifically seasonal affective disorder. This is a disorder that's more common, especially in areas that have very high latitude in the northern hemisphere or very southern latitudes in the southern hemisphere. In other words, closer to the poles, where in the wintertime you can go for weeks, potentially, depending on what time you wake up, without seeing the sun. And in this type of a situation, they actually have something called SAD lamps that have been shown that if you put people on these SAD lamps that give out about 10,000 lux of light, to as a comparison, the sun on a bright sunny day is about 100,000 lux. So this is 1/10 of that. And yet still, looking at that for about 20 minutes, about 11 to 16 inches from your head, that's about, that's probably about, 45 centimeters or so. That can actually reduce the incidence of depression. So to summarize the question and the answer, why is it important to expose your eyes to bright light in the morning? Number one, it solidifies and stabilizes your circadian rhythm, telling your body that yes, this is the morning, and it's time to start doing all those things that are best for the morning. That's number one. But number two is it reduces the incidence of mood disorders such as depression.
And it sets the stage for later on at night when you go to bed. It already starts right there. And we'll talk about that a lot more as we go. We had Martin Moore-Ede here. I'm sure you know him, of course.
Oh, yeah.
They discovered the central clock, he said something interesting. He said that actually our natural rhythm is a little bit, out of the 24, hours. So when we resync it in the morning, you're well synced, so to speak, because the way I look at it, not only do we have trillions of cells, we have many mitochondria in most of our cells, except the red blood cells. So there are trillions, and they all do their things. They don't do it randomly. So you can think we have trillions of clocks. And there's a central. So, when you are reset, I think, like Disneyland, it starts you off in a good way.
Exactly. Yeah, 100%.
Okay, now, if you don't mind, let's go a little bit deeper into the light of the sun. And so we know we have the spectrum. We have the visible light and then the non-visible light on both sides. So of course, in the morning, when you go out, UVA and UVB still are not present, but you get a fair amount of red and the other side of of the visible light, which is non-visible, near infrared. And then of course the far infrared and blue, you get blue. So we know that technically blue also is a signal to your brain, hey, it's daytime. You need to be up. You need to be alert. That, of course, will cause damage later on at night, which we'll talk about. But all of those. So in the morning, you have an abundance of red and infrared and blue, let's just say. What do those things do now that we go into those wavelengths a little more?
Yes. So that was the second aspect of light. We talked about what interacts with the eyes and the mitochondria in the eyes and the visual pathways. Let's talk about the light that can actually penetrate into your body, not where the eyes are, but into the cells of your body. So Dr. Glenn Jeffrey, who is a professor in the Department of Ophthalmology at University College London, recently published a study in Nature Scientific Reports, very elegant study where he was able to show that taking subjects outside at high noon, that the sun was able to pass through, and specifically the longer wavelengths that we're talking about here, that type of light was not only able to penetrate through the clothing of these people, although in the first part of the study, he actually did them without shirts on. 30 centimeters of thorax it was able to penetrate through, and they were actually able to measure a measurable amount of light coming out the other side that had with it the same pattern as the sun in the longer wavelength. And what he was able to show was that that not only does this infrared light pass through the body, but it's also absorbed in large amounts, because a very small amount came out the other side. Very large amounts of this are being absorbed in the body. So why would he do this? The reason why he would do this is because there's ample evidence, not only by his lab, but also Scott Zimmerman, Russell Ryder. These are scientists that have published also in the Journal of Melatonin Research, that shows that this type of infrared light, this long wavelength light that you cannot see, interacts with the mitochondria in the cells and produces a number of factors, of which they believe melatonin is one of those. And it upregulates the amount of output of ATP, which is the sort of the currency of energy in the cell, and makes the cells more efficient, and they're able to actually metabolize more. And they were able to detect this in another paper of Glenn Jeffries, where he did this on subjects with light on their back. He was able to show that not only was the glucose reduced after a glucose tolerance test, showing that, in fact, the mitochondria were revving up, but the byproduct of all of this, which is carbon dioxide, was also increased in exhaled breaths in these very subjects. So to get back to your question then, is what's going on with these wavelengths, these invisible wavelengths, things that are very specific to the sun, is that it has a tremendous impact not only in our body, but by the way, also in the light that goes into the eye, especially at the back of the retina.
Okay, so now one thing you said now was new to me, because normally when you and other scientists talk about the penetration of near infrared into the body, you talk about 8 centimeters. You just said that Glenn Jeffries showed 30 centimeters. 30 centimeter is your entire torso. I mean, It goes in and out.
So the initial data on that was 2019 by Scott Zimmerman and Russell Ryder. They published a paper called Melatonin, the Optics of the Human Body. And it's published in that paper in 2019 that 8 centimeters was what they measured. This is a brand new paper that was literally just published this month that showed that 30 centimeters is what this can penetrate through.
Okay, so for the listeners, we just go through the spectrum of light. We have the visible light, the colors. It's the rainbow, the colors of the rainbow, where red would be the longest length, of the waves. And then at the shorter end, right below the visible spectrum, we have UVA, and then shorter than that even is UVB. There's also UVC, which, by the way, it turns out has something to do with what happens inside of us, but we are going to leave it alone for now, because it doesn't really reach the Earth.
Right.
But you have UVB, the shortest one that reaches us, UVA, and then you have the visible spectrum till red, and then comes the invisible infrared spectrum. Now, most of the benefits that you talk about as relates to the mitochondria have to do with near infrared light. Is that correct? Maybe.
Yes.
What's the wavelength?
Well, it's interesting because Glenn Jeffrey has tested both 670 nanometers, which is in visible spectrum and is red, and it's worked there in terms of reducing glucose. And then in this most recent paper in Nature Scientific Reports, he used 850 nanometers and was able to show an improvement in vision, even though the beam was not going over that part of the body.
There are so many questions here, many questions. So I don't even know where to go. I'll just randomly say the first one that comes into my mind. If you go to a library, not that libraries exist as much as they used to, but if you go to a library, you'll see there's a whole shelf on red light therapy. And many of those books will be on red light and near infrared light. So indeed, people are very enterprising, and there are many red and infrared panels. And some of those panels were actually used in some of those experiments. But a very basic question that I have, never mind that you have to navigate which panel to use and the risks associated with, EMF, so maybe it wasn't well built. Assuming you found a panel that is built very well, people would say, or we would say here, it's beneficial to have a panel that brings out red and infrared.
Yeah.
But my question is, why do we need a panel where all we need to do is open the door and step outside, and we have a much better panel, not 670, but 671 and 672, and not 84. But, why do we need a panel when we have the sun?
I 100% agree with you. It must be a characteristic of human behavior that we try to take what is good for us and try to make it into something artificial. I don't know the answer to that. I think the question is really, are these panels simply replacing what we would normally get from the sun? And I believe the answer is yes, and there is some data to this. So there was a paper that was looking at this, and they were in this environment where they were surrounded by LED lights inside in an office building. So in other words, in an area that's not bathed in infrared light that you would get outside. And what they noticed was this, that when they introduced these types of panels at their desk so that they would get infrared light and red light, just like we're talking about now, they noticed that it didn't have the same effect in the summertime than it did in the wintertime. Now, why would that be? Obviously, people are much more likely when they go outside after work, after they're not working in that environment in the summertime, to actually get some of that infrared light from the sun, and less likely in the wintertime, obviously, because the sun gets up late and goes back down early. And so to me, those findings imply that these red lights, these red panels, are simply a poor substitution for a very overall damaging problem with what we have, which is infrared light deficiency. Think about it this way. Imagine you're on a British ship 300 years ago. Okay, this is when scurvy was at the height of the thing, and of course, imagine that you're passing out these lemons to people, and the scurvy is going away. Their gums are no longer bleeding. They're able to do very well. It's a miracle, right? And then you realize that that a few of these people are maybe having a little bit of lemon juice on the side previously, okay? A tiny small amount, so that they're able to have just sort of a mild scurvy, or maybe not scurvy at all. Do you think the lemons are going to help those people on the ship from the mild or no scurvy that they might have? And of course, the answer is no. It's not going to do that, because it's not replacing a deficiency that they have. They don't have a deficiency. And so what all of this means, I think, if we boil it down here, is that I believe that red light panels in general, okay, are beneficial only because of the 21st century scurvy that we have today, which is lack of getting outside, lack of sunlight, and these sorts of things. I believe that if we were to take these red panels and go back 50, 60, 100 years ago, I don't believe that they would have the same benefits. Of course, I can never prove that, but if we go to other cultures of the world, cultures that have plenty of sunlight, good question, would these panels work on that population? I'm not sure. I would be very interested to see if they do. Now, that being said, in my profession, certainly there are patients that are in the intensive care unit that it's risky for them to get outside. I mean, they're hooked up to oxygen, to ventilators, to drips. To get these people packed up and mobile, to get them outside, is a noble cause. But sometimes the risks outweigh the benefits because they're just so unstable. So do I think that there's no role for these panels? No. I think there is a role especially for people who can't get out into the sun. But if you could get out into the sun, that's your best bet.
I agree it makes so much sense, especially since even when we talk about the panels, we assume a perfect panel, and maybe they're not perfect. Maybe some of them are not made well. The sun is made pretty well, I think. So we can count on that. But if we go on the trajectory of the infrared light, we have, again, in the majority of the cells in the body, we have a number of mitochondria. And the mitochondria creates, ATP through the electron transport chain. There's a whole process. How does infrared light, which we know can penetrate certainly deep enough to hit every cell in mitochondria, an organelle, how does it stimulate? What does it do to our mitochondria?
That's a very good question. That's the $1 million question. We don't know the exact mechanism, although we have some clues. We see that melatonin for sure is actually being actively made in the mitochondria. We know that its levels rise when it is exposed to this type of light. We know that there are certain proteins in the electron transport chain that have receptors for light. That's for one of them is called cytochrome 4 oxidase, and that chrome portion of its name implies, of course, that it actually has color to it, which means it's absorbing light. There's a number of factors. We know that nitric oxide is produced in the presence of infrared light. So there's a number of areas that scientists are working on. But what we can do is we can say this, that based on randomized controlled trials produced at UCL, University College London specifically, it is shown that the presence of infrared light not only reduces the fuel, in other words, it increases fuel consumption, increases metabolism, it also increases carbon dioxide. And all of those are things that happen at the mitochondrial level. So where the details may still be being worked out, the concepts are there with very good evidence. So if you look at oxidative stress, which is sort of the heat in the engine that has to be dealt with, oxidative stress is the product of basically oxygen, which we breathe into our lungs and is converted into water. Well, that happens in the mitochondria at the electron transport chain. And when that doesn't happen perfectly, there are chemicals that are produced that lead to oxidative stress. Things like superoxides, hydrogen peroxide, hydroxy radicals. All of these things can be mopped up very efficiently with the most powerful antioxidant that we know of, even more powerful than glutathione, which is melatonin.
So this is actually a very important point for everybody who is listening to us now. The conception or the concept of melatonin is it's the sleep thing. It's produced in the pineal gland. Now you're saying Zimmerman and Ryder showed, yes, but it's also made right there in the mitochondria. And I think you used a wonderful, analogy. You say you have a car engine that runs and runs and runs, and it gets heated, and that's the reactive oxygen species and all the other things that you mentioned. If you let the engine just work and not cool it off, well, it's going to blow.
Yeah.
So you're saying we can almost use an analogy that melatonin serves as the coolant to the engine that is the mitochondria that makes the energy. And it's made in the mitochondria, which means everywhere except the red blood cell. I mean, everywhere in our body, we make melatonin all day long, not just at night or anything like that. That's actually a huge statement.
Yep. And it's interesting. The reason why we're now finding out about it is because it's not detectable per se in the blood like we would see with circadian rhythm melatonin production in the brain, the pineal gland. Instead, this is made not only just inside of a cell, it's inside of an organelle inside of a cell. Right. So it's really difficult to get down to that level and actually measure it. But there are some ways of doing it. It does leak out sometimes into the cell and into the sweat, for instance. So there are sweat monitors that can actually pick up melatonin, and what they're finding is that even though pineal melatonin production is essentially zero during the day because light is coming into the eye and it's shutting it down completely, as it should, we're able to measure melatonin spikes on these sweat sensors that people wear that are actually looking at this from a research standpoint.
This is fascinating. Now, I want to clarify something for our viewers. You mentioned the emission of carbon dioxide as a measure for a positive effect. People are associating those words with something negative. So can you talk about it just a little bit?
Yeah, we make carbon dioxide as a byproduct. So if you think about carbon, we're carbon-based individuals. And the carbon that we consume have to be high energy carbons. So what are high energy carbons? It's carbons that are connected to things on the left side of the periodic table. So hydrogens. So that's why hydrocarbons like fuel, like gasoline, like diesel, like sugars that we eat, fats that we eat. This is where energy is. And whether you're talking about animals, whether you're talking about engines, the energy that comes from running those things has to come from high energy carbons. Now, what happens in the process of extracting that energy is that these carbon atoms eventually are connected to things with very low energy, and that would be oxygen. So the lowest oxygen that goes into the body combines with carbon, and the product is carbon dioxide. So carbon dioxide comes out of engines, carbon dioxide comes out of humans. It is a natural product of animal or human or any sort of metabolism. The good news is that trees take this and they re-energize these carbons with light from the sun in a process called photosynthesis, releases the oxygen once again to be used, and stores the carbon inside of its plant, fruit, whatever product that the plant makes. And so it's sort of the other half of this cycle of what humans do and what things that photosynthesize does.
Yes. So, I mean, when we talk about trees also, and you bring this example, trees usually have green or greenish leaves, and says something about the color green and its absorption. But you also say that trees and greenery reflects near infrared light.
Yeah.
And it can be shown in near, in cameras like.
Absolutely. So let's start from the 30,000 foot level, literally. The way that we can measure the size of a forest and keep an eye on things like deforestation or reforestation is simply by measuring the amount of infrared light that reflects back into space. So we actually have satellites that measure infrared light and can very accurately measure the amount of foliage and green spaces from space. But you don't need to launch a satellite to see that. You can simply take an infrared photograph and of trees and leaves and things of that nature, and you can see that they light up like a Christmas tree. They're very bright in this situation, and they reflect a lot of that light back to you. So you can get actually much more infrared light if you're in a green space. And that's really important because they've done some research on this. We've known for decades. You could go to your AI engine or Google and type in, do people who live in green spaces have reduced incidence of diabetes? The answer is yes. Do people who live in green spaces have a reduction in cardiovascular mortality? The answer is yes. Do people who live in green spaces have a reduction in all-cause mortality? And the answer again is yes. And the reason for this, I believe, is that people who live in green spaces are getting more of this infrared light, especially today, than we ever used to get, than we do today. And maybe not more than we used to get 100 years ago, but certainly more than we get today. I think the most impressive evidence of this just recently and was published about a year ago. So the premise was, the explanation was that, yes, people who live in green spaces have a lower mortality. They have a lower all-cause mortality, a lower cardiovascular mortality, a lower rate of diabetes. Why is that? It's because the people, they said, who tend to live in these places have more money. They're able to be more upwardly mobile. They exercise more. It's the population that we're dealing with, and that's the reason why that there's so much better. Well, there was something called the Green Heart Study that was done in Louisville, Kentucky. And what they did was they measured something called the highly sensitive CRP levels. This is a measurement of inflammation in the body, and it's a surrogate for what your chances are of getting a stroke or a heart attack. So you don't want a high number, you want a low number. But they went around and they measured about 700 people in a 4 square mile area of South Louisville, Kentucky, kind of urban, not a lot of trees, a lot of buildings, things of that nature. And so they measured it. And then what they did was something extraordinary. They actually got and dug a hole and planted 8,000 mature trees. That means with leaves on them. We're talking about specifically leaves here and how they reflect infrared light. And then they went about 2 to 3 years later and they measured everybody's highly sensitive CRP levels. And they saw something amazing. There was anywhere between 13 and 20% drop in the same people that they measured. Even though there was no increased incidence of exercise, they didn't sort of give out money to increase their social mobility. This was literally just planting trees in an area of urban sprawl, and they were able to reduce the HSCRP levels by that much, which translated into about a 15% reduction in stroke.
That is absolutely fascinating. That is completely fascinating because it also shows a secondary point that you don't need to be in the midst of the green. In this case, the green was in the neighborhood because, you'd say, okay, I want to go out in my garden. Shall I go and hug my tree? Shall I be so close to the green? Apparently, at least from this experiment, just be in the general vicinity. We had somebody on this show a couple of years ago from the University of Nippon in Tokyo, who is also a researcher at Stanford. And he talked about forest bathing.
Yeah.
He talked about all the facets, the smell, and there's a specific tree that you can distill the smell, and they measure everything all the time. And even the visual, they put people in a hotel room with pictures of trees, and they could already measure. But I mean, obviously...
It was the Hinoki cypress forests in Japan.
Right, exactly.
Yeah.
And so the infrared wasn't mentioned explicitly. I'm sure this is a major part of it.
Absolutely. In those studies, what they were looking at are natural killer cells and the granulozymes and things that were inside those natural killer cells. And they showed that they increased not only when they took them up and had them walk around in the forest, but also when they infused that essential oil, the Hinoki cypress oil, in the hotel rooms in downtown Tokyo. Interestingly, though, as I recall from that study that he did, there was a number of studies that he did, that the cortisol levels in the urine were lower in those that were actually in the forest compared to those that were in the hotel room. So there are a few things that you can replicate, but I would say again that fresh air, or the air that you breathe in the forest, not only is made up of these phytoncides, as they call them, these things that are found in the trees, the Hinoki cypress, multiple chemicals that are beneficial for our immune system and can last up to a week, even a month in some cases, as they found in that study. But there's also bacteria and beneficial bacteria. So we all know about the gut microflora that's beneficial. Now we're starting to understand that more. There's actually a respiratory, if you will, an air microflora that actually has shown some benefit. So I used to believe that, fresh air and the best type of air was air that was completely clean and had nothing but just nitrogen and oxygen. But my thinking is coming around to this, that the complex systems that we have in nature are actually designed for our benefit.
People have always naturally gravitated to green. And I understand the argument about the money. Anybody who has money and builds a fancy home, one of the fancy things would be a garden and trees. But even people at any socioeconomic level will get a plant, will plant flowers. There's always been a tendency to seek that, and probably the infrared, not that people necessarily know what it is, but it feels good.
Yeah, no, it does. There is some data that I've just gotten from Bob Fosbury that I need to sort of process and put out there. He may be getting ready to publish it himself. I'm not sure, but he's taken a number of photographs of this fern that he has. And Bob Fosbury, by the way, for those who don't know, is an astrophysicist. He's collaborated with Glenn Jeffrey on a number of these projects. He's also in the Department of Ophthalmology at UCL. And it's amazing on the histogram of the spectrum of light that even when you're, like, for instance, underneath a fern tree in a corner tucked away where it's dark, the visible light is at a minimum, but there's actually quite a lot amount of infrared light. And this is very hopeful for me, especially for people who are concerned about getting skin damage from ultraviolet. And there's a debate about whether or not ultraviolet in the setting of the sun actually can cause damage when you're only out there for a short period of time. But for those people who are concerned, there are things that you can do to mitigate a lot of that visible ultraviolet spectrum and still get plenty of infrared light, especially if you are in and around a garden.
Okay, now I'm going to jump all the way to the other end of the spectrum from the near infrared, and I'm going to go straight into what you just mentioned, the UVB, the shorter one.
Yeah.
So we know that UVB, when it hits your skin, stimulates the production of vitamin D, as in David. It's beneficial. However, many would say, and if you go to a lot of dermatologists, although now there are many dermatologists that are starting to come around, but the standard will still be no tan is a good tan, don't be in the sun, UV will damage your skin. But if we look even at the shortest wavelength, which means the highest intensity light that could maybe cause the most damage, UVB, we do know about the positive things. It creates vitamin D, and people could say, oh, you can supplement, but we'll talk about that in a second.
Yeah.
But it also, we know, about, the POMC,
Yeah.
which cleaves into 9 different products, including, endorphin. Somebody, I don't know who it was, maybe Jack Cruz, said we were designed to be addicted to the sun because UVB on our skin creates endorphin.
Yeah.
When the POMC cleaves and many other beneficial products. So, I kind of think this is a place where there is a lot of tension
Yes.
these days between, and I want to suggest something and I want to see what you think about it. Thanks for joining me today. Click the subscribe button for more video. Got a question or comment? I love questions and comments. Leave yours below. And here's another video you've got to see.